Alright gentlemen, we're going to review in module number 2 the EQs entitled Differences between Low Voltage Thermostat Terminals, Air Handlers versus Heat Pumps and ACs. And I've given you 3 resources that talk a little bit about the differences between heat pumps and ACs. And then we've spent a lot of time on gas furnaces as well. What is a heat pump? It's simply a device that uses a refrigeration circuit to pump thermal energy from one space to another. It's inaccurate to say an AC cools your house. A more accurate description would be it takes the thermal energy in your house, in the air, absorbs it in the refrigerant, pumps that refrigerant outside, and gives up that heat energy to the ambient air outside. So the evaporator is inside your house, the coil is a heat absorber. You pump it, and the outdoor coil is a heat rejector. In the winter, you can reverse that flow and take heat. Even though it's cold outside, you can take thermal energy from outside, concentrate it in the refrigerant, and then pump it into your house, manipulate the temperature by pressure to warm up your home during the winter. So what is a heat pump? It's a device that pumps thermal energy from one space into another. What is the major difference between a heat pump and a typical AC? A typical AC can only cool your house or lower the temperature in your house. A heat pump can lower the temperature in the summer and raise the temperature in the winter. It can heat and cool. Which components can you find on a heat pump? Condenser, that's the outdoor unit typically. Referred to as the condenser. Which components can you find on a heat pump condenser that you cannot find on a typical AC condenser? On a heat pump, you'll find reversing valves, which change the flow. You'll find defrost boards, which in the winter, a heat pump, the outdoor coil is below freezing. So it's always freezing up like an igloo. So you need a way to melt the ice off the coil to keep airflow. So you'll have defrost boards that an AC doesn't have. An AC will only have a contactor. Defrost boards can come in demand with thermistors, or time and temperature with just a 30-second, 90-minute clock, runtime clock, and a thermostat. So the other thing a heat pump will have, it does get to the point outside where it's so cold you can't concentrate enough thermal energy in the refrigerant to keep your temperature in your house to meet the heat load, to keep it warm enough. So you have to have resistant strip auxiliary emergency heaters on the indoor air handler above your blower motor. So the components you can find on the condenser unit are defrost board and defrost sensors, and you can find a reversing valve. What 2 types of defrost will you typically find? Time and temperature, which uses a thermostat and a run timer. It's just a 30, 60, 90-minute run time timer that will go into defrost, pump hot gas in the outdoor coil and melt it off, which is very inefficient. Or you can get a demand defrost, so time and temperature or demand. Demand uses thermistors and algorithms to go into defrost in a much more efficient, less common, less frequent way, but they're more likely to fail. What is the major difference between gas furnace and heat pump air handler? A gas furnace has a combustion box and a heat chamber to burn and utilize the heat from burning fossil fuels, natural gas or LP, compared to an air handler that has a blower motor tied to a coil and resistant strip heaters. So the indoor unit on an air handler or on a heat pump is typically called an air handler. The indoor unit on a gas furnace AC is obviously called a gas furnace. They both have blower motors in them. They both move air across the coil to cool. but one will burn fossil fuels, the other one will use thermal energy pumped from outside inside to heat. Which components are unique to a heat pump air handler? Components you won't find on a basic AC air handler: resistance strip heaters or auxiliary heaters, also known as emergency heaters. And oftentimes on an AC only air handler, you won't find a control board. On all heat pumps, you'll find a control board that will control the sequence of operations. Which low voltage signals are considered inputs going into the thermostat? If you remember, we diagrammed this. That's the common and hot, the C and R. The blue or black usually for C, and the red for R power your digital stat. They send 24 volts to it. Which low voltage signals are considered outputs from the stat? That would be everything else. So when R closes to G, it brings on your fan. When R closes to Y, it brings on the contactor outside to cool. When R closes to O, it puts it in a heat pump in cooling mode. When R de-energizes O, it switches the reversing valve solenoid and runs in heating mode. When R closes the W on a gas furnace, it brings on the heat sequence or the gas valve to burn and turns on the blower. So everything else out of a thermostat is an output. Only C and R are inputs. What is the only typical output from a defrost board? Going out inside to the air handler to provide heat during a defrost cycle. So we talked about this. It's kind of anti-intuitive. However, let's see if I can blow this up. Yeah. Okay. Wish I could make this bigger. It is what it is. Down here at the bottom, it might be hard to see. You'll have XL, which is an alarm light, R, which is 24 volts hot, C, Y, O. C is common, Y is your outdoor contactor, O is your reversing valve solenoid. W is an input to let it know that the heaters are on the indoor. And then you have W1 often, which is an output. So what happens during a defrost, you have a condenser fan that is broken through this relay. It will turn off your condenser. It will kill 24 volts to your O terminal. It will essentially run AC in the winter. So, in order to melt the ice off your coil outside in the winter on a heat pump, you have to run air conditioning in the winter. Trust me when I say customers are going to get upset if you're running AC when it's 10 degrees outside. But you have to or the heat pump won't work. As a result, this W166 is an output. XL and W1 on this board are the only outputs, but XL will send a signal to bring a light on your thermostat to let you know something's wrong, where W1 will send a signal into your strip heaters in your air handler to turn on your strip heat only when it's defrosting to prevent you from blowing cold air inside during a defrost cycle. So, back to that original question. What is the only typical output, because not all of them have alarm light XL. What is the only typical output from a defrost board going inside to the air handler to provide heat during a defrost? That would be the W1/66 terminal to bring on the strip heaters on the indoor. That was very fast. If I went way too fast for you, ask a question or review these 3 resources to prepare for your midterm. Do you gentlemen in class have any questions? All right, guys, feel free to eat. Oh, okay. feel free to email, text me, call me. Get ready for your midterm. As you work through this, if I don't get back to you quickly enough, call me again. Let me know it's important to you, and I will meet you Wednesday at 11:30 to take your midterm.